Hi, thanks for joining me today. I'm going to be evaluating a fun integral. It's sort of a classic problem, but yeah, this is the one I'm going to be tackling today. It's the integral from 0 to 1 of log x plus 1 divided by x squared plus 1 dx. Okay, there are a couple of different ways you can evaluate this integral, so if you want to have a go, pause the video now and give it a go. Try and evaluate the integral yourself, and join me in just a second where I'll get stuck into a solution. Okay, so the first thing I'm going to do to evaluate this integral is get rid of the x squared plus 1 on the denominator. Whenever you see an x squared plus 1 on the denominator, a standard way to get rid of it is a sort of u substitution. So it's going to be x equals tan theta. And the reason for this is it works out really nicely because when you put tan theta into this thing here, you get tan squared theta plus 1, and a standard identity tells you that that's secant squared theta. But when you do dx on the top, you get dx equals the derivative of tan theta d theta, or the derivative of tan theta is sec squared theta, so secant squared theta. So you get secant squared theta on the top, secant squared theta on the bottom, and they both cancel really nicely. Okay, so let's do this substitution then. Okay, and if I call the integral that we're trying to work out I, okay, if we just plug this in, when x is 0, we get tan of theta, so that means that theta must be 0. And when x is 1, theta would be pi over 4, because tan of pi over 4 is 1. Okay, and log x plus 1 simply becomes log of tan theta plus 1. And on the bottom, like I said, I get x squared plus 1, which is tan squared theta plus 1, which is secant squared theta. And then our dx becomes secant squared theta d theta. So all of a sudden, this thing and this thing cancel, and we're just left with integral from 0 to pi over 4 of log tan theta plus 1. Let me rub this off, we'll bring this up to the top and continue. Okay, so the next thing we're going to do is another u substitution, and what we're going to do is simply do the one which switches the limits of integration. So it's going to be, let's say u is equal to pi over 4 minus theta. So if you've not seen this before, this is a really cool trick. If you've got the integral from 0 to say a, where a is some number, in this case a is pi over 4, if you do the u substitution, u equals a minus theta, you get the order of the limits will change, but then your d theta here will become minus du, and the minus sign means that you can bring these limits back to normal. So then you're getting that this integral equals some other integral but with the same limits. Okay, so in this case we've got the integral when theta is 0, u is pi over 4, and when theta is pi over 4, u is 0, and then our integral becomes log tan theta is now tan pi over 4 minus u. Okay, and then plus 1, and then d theta is minus du. But the minus sign here, I can get rid of it and swap the limits of integration. So let's just do that. So the integral from 0 to pi over 4 of this thing here. Now what we're going to do is use our double angle formula on this thing here. So this is tan of pi over 4 minus u. So that's precisely tan of pi over 4 minus tan of u. Minus tan of u. All over 1 plus tan of pi over 4 tan of u. And remember we still have that plus 1. Okay, now tan of pi over 4 is just 1. So I can get rid of this one here and write 1 minus tan u, and then just get rid of this tan pi over 4 on the bottom. Okay, and we still got that plus 1 out here. Now let's bring everything under one common denominator. So it's going to be 1 minus tan u plus 1 plus tan u, all divided by 1 plus tan u. So let me just write this on the next line. Okay, and I'm just going to swap the u for theta, because remember u in this case is a dummy variable. It doesn't matter what letter we use, it's still going to be the same thing. So this is log of 1 minus tan theta plus 1 plus tan theta, which is of course going to just be 2, because the tan thetas cancel, divided by 1 plus tan theta d theta. Okay, now this looks perhaps like an even crazier integral to evaluate, but here's where a really nice trick comes into play. We can use log rules and compare this integral with this integral here. Firstly, the limits are the same, so if we were to do this integral plus this integral, we could bring it all under one integral sign. But also we've got log plus log, so that means we can just do log and then multiply the two inputs. But then when we multiply the two inputs, we've got a tan theta plus 1 on the numerator and a tan theta plus 1 on the denominator, so it's going to cancel quite nicely. Okay, so let me rub out this sort of middle line and I'll put it here. So this thing here is also equal to I, the thing we're trying to work out. We're going to do this thing here plus this thing here. So on the left hand side we just get 2I, and on the right hand side we get the integral from 0 to pi over 4 of this thing plus this thing. But as I said, we can use log rules to show that the tan theta plus 1 there will cancel with the 1 plus tan theta on the denominator there. So it's just going to be the integral from 0 to pi over 0 to pi over 4, sorry, of log 2 d theta. Now of course log 2 is just a constant, so I can bring it out, and then it's just log 2 times pi over 4. So then that means that I is just log 2 times pi over 4 over 2, which is just pi over 8. And that's our solution. Okay, so I think this is quite a neat solution. We had our original integral being this thing here, the integral from 0 to 1 of log of 1 plus x divided by x squared plus 1 dx. And using a few tricks, some u substitutions and things like that, we've got it into this quite nice form here involving logarithms, pi, and the number 8. But yeah, anyway, that's today's video done. I hope you have enjoyed it. If you are new here, please do consider subscribing and checking out some of my other fun videos as well. But yeah, that's all for now. I'll catch you in the next one. Have a great day.